Hello, we are from Group 5. Our topic is one of dust explosion case in Malaysia that happened in early November 2010 at Pulau Pinang. Our team members are Desy, Hikmatul, Siami, Naufal, Alif, Ganisha, Vista, Ayudya, Octaviany, and Wafa, Natasha, Binti, Welson. In early November 2010 at Pulau Pinang, the rim manufacturer factory was burned down due to a combustible dust explosion from the pulsing activity in making rim. From investigation, the origin of the cause was found to start from the fire and resulting with explosion in ducting system, which transporting the aluminum dust to the tower dust collector. By this incident, 8 workers were injured, and 2 of them received serious injuries. This explosion also caused damage to buildings, manufacturing plant, and destruction of dust collector system. In the area where explosion happened, there are some factories nearby. This explosion also broke the windows of those factories.
In the early November 2010 at Pulau Pinang, the rim manufacturing factory was burned down due to combustible dust explosion from the polishing activity in making rim. From investigations, an explosion occurs due to a small fire from the polishing machine and causes a chain of dust explosion, which means the origin of the cases was found to start from the fire and resulting with explosion in ducting system, which the aluminum dust is transferred to the tower duct collector. When we refer to the old theories of combustion occurs when fuel dust like combustible dust is exposed to heat, such as the ignition source in the presence of oxygen, which we know that mechanism of dust explosion may occur with the existence of 5 elements such as oxygen, heat confinement, fuel, and dispersion. The causes the production of combustible dust explosion is from the presence of 2 other elements, which are the particulate matter and the limited space. This impact have been caused and injuries about 8 workers and 3 factory areas was destroyed.
To trigger a dust explosion, even the industry, as an engineer, we must be aware of the potential that can cause a dust explosion. But before we see the dangerous potential, we must first identify factors that can contribute to the explosion based on OSHI recommendation to provide service from all materials used in industry. The whole process is used including the finished product, entire room including hiding room, and the last anything that causes fire. And next, I will explain how to control dust and fire. First, how does control? We can perform program inspection, cleanliness and testing. Second, use a good dust collector or dust filter. Third, design surface that reduces dust build up and clean regularly. Fourth, the distant process can reach hidden areas. Easy to reach or available access. 5. Check for residual dust regularly, either in open areas or in areas that are difficult to reach. 6. If the area is creating sparks, use a method that does not create a dust cloud. 7. Use only a vacuum cleaner that meets the standard for cleaning flammable dust. And the last, the relief valve must be positioned away from the place where dust accumulates. Now, how to prevent heat or fire? First, you can do good wiring method and using suitable electrical equipment. Second, prevent statistical electricity by using constraint and earthing. Third, prevent spark due to friction or mechanical impact. Fourth, remove foraging matter that could cause a fire from the material. 5. Prevent dust from being exposed to hot objects, example, under lamps, on electric motor, on steam pipes, or another, because heat can cause dust to burn. 6. Select and use lifting equipment. Save transportation from the possibility for generating spark. 7. Use equipment that does not create spark. And the last, implement a preventive maintenance program.
Next, safety regulation. Applicable OSHA requirement include General Duty Clause Section 5(1) of the Occupational Safety and Health Act. Employers must keep workplace free from recognized hazards likely to cause death or serious physical harm. OSHA 19 and 10.38 Emergency Action Plan. Point 39 Fire Prevention Plan. Point 94 Ventilation. Point 157 Portable Fire Extinguisher. Point 178 Power Industrial Truck. Point 269 Electric Power Generation, Transmission and Distribution. Point 272 Current Handling Facilities. Point 307 Hazard Classified Location. And the other regulation from the National Fire Protection Association consensus standard and document related to this hazard, and FPA 68 Standard on Explosion Protection by Deflagration Venting, and FPA 69 Standard on Explosion Prevention System, and FPA 484 Standard form for combustible metal, and FPA 654 Standard for the prevention of fire and dust explosion from the manufacturing, processing, and handling of combustible.
The near miss reported today is the accident that doesn't happen tomorrow. That's all from us. Thank you for watching and see you later.